They say your high school teacher is gonna make you like code it in. And it never happened.
Yeah, I think it's.
They just wanted to mess with those 8th graders.
Unfortunately, and this was not you all, unfortunately there are kids that came to me from the middle school that are in CP Algebra 1, and you want to know what they did in 6th, 7th, and 8th grade? Nothing.
Me too.
And then they're doing bad with me, and it's like, why am I doing so bad? It's like, well, you did nothing for 3 years.
I've done nothing for 6
My
years.
You've done quite a bit, buddy.
Like,
Okay.
mine taught me.
What kind of was 12B last night, right?
Yeah.
So, any questions you wanted to?
The last two.
Last two, we did evens, right? Or odds, sorry. So 21 and 22?
21 and 23.
21 and 23, because I know 21 and 23. Perfect. Alright. Alright, number 21, we got x squared plus 2x equals y minus 5. And transform the equation into vertex form and then identify the vertex. Okay. So we have to complete the square here. Complete, if I could spell. Okay, so I'm going to do x squared plus 2x, leave a blank. Okay, and this is how I teach completing the square. If I go here, I'm going to make myself a binomial. Agree? I'm going to bring the x down. This sign is always the same. If that was a minus sign, it'd be a minus. It's a plus here. What is half of 2? 1. What is 1 squared? 1. If I add 1 and I have an equal sign, I can add 1 over here. Is that okay so far? So if I went x plus 1 times x plus 1 and FOILed it, I'd get this. So it's a perfect square trinomial. And then I can combine my like terms. Get that? Whoops. This is supposed to be a y. I'm sorry. That's a y there. That's a y there. That's a y there. Okay. And then maybe just clean it up. Having y by itself. Add 4 to both sides. Is that okay?
Okay.
So this one's nice. This is just a regular parabola. So I get negative 1 comma 4 for my vertex. Okay? So completing the square sometimes is the tougher mode, though it's actually the most accepted form of how to solve these. And then I can't even tell you the problems that the quadratic formula has. I actually don't think it should be taught, but because the amount of arithmetic errors that take place. 12x minus 3 equals 2y plus 5. Okay, so this is still going to be a normal parabola. We're just going to complete the square on it. So I can do one of two things. I can move the 3 over first, or I could just make a space. Doesn't really matter. I'll go ahead and just move it over and leave the space there. Do you agree with the math I just did? Okay, so let's see if we can walk through completing the square. So I'm going to have this. X comes down. What's the sign have to be? Always that sign. It's always the linear term. It's always that sign.
X minus 6.
X minus 6, because half of 12 is 6. 6 squared is plus 36. And add 36 over here. What is that going to be? 44. Okay. I can move the 44 over. And then I can divide everything by 2.
Oh, so it's a shrink.
Okay, so yeah, it's a shrink. It'll be a fatter parabola. It opens up. My vertex is going to be 6 comma negative 22. The half won't influence that. Any other questions off the homework?
Seventeen.
17. X minus 4 equals negative y squared. Is that one? Okay. I don't like the negative on the y squared, so I'm going to change it over to here. you think?
It's the left 4. The right 4.
Yeah, so square root it. Make sure you have plus minus here. So this is actually going to be a sideways parabola if we solve this way, isn't it? Yeah, because that's going to be at -4. What does that negative x do? Negative x.
Does it just flip the direction?
So let's see, if I plug in 1. So let's explore what this is going to do. Let's just do x, y, -2, -1, 0, 1, and 2. If I take -2 and plug it in, I get negative, that becomes 2, that becomes √6. If I plug -1 in, that becomes √5. Plug 0 in, that becomes 4. Plug 1 in, I get √3. Oh, wait, that's √4, so that's 2. Sorry. Plug 2 in, I get √2. Plug 3 in, I get, let's see, what would I get? And then I have the plus or minuses of each of those. So each of those are plus or minus, plus or minus, plus or minus. Plug 3 in, I get √1 plus or minus, so that's √1, so plus or minus 1. Plug 4 in, I get √0, which is just 0. Plus or minus doesn't take place. If I plug 5 in, that's going to give me the plus or minus √1. Okay, so -2 √6, I don't know, it's like here and here. -1 √5 is like here and here. And 0, 2. Oh, wait. What does my graph look like? Let's plug. Let's just get rid of that. All right, so 0, comma, +2, -2. So I'm going to plot that because I see that right away. And then let's plug values we know. 3, comma 1, -1. And then 4, 0. There it is. And that's actually what that would look like. So I didn't plug the roots in, I just plugged the exact values in.
Nice.
We good?
Yep.
All right, make sure, yeah.
You just added 4 to well,
Yeah, definitely. So, all right, pass those in, please. Make sure your name's on them. Did the no-namer find a home? Was this class one with the no-name?
Yeah.
Uh-oh. Where did the packet of stuff get to?
Did we already do circle stuff this year with like maybe the unit circle and stuff?
Yeah. So we're not going to deal with the unit circle at this very second, but all right, let's go back. All right, so we're going to expand what we know about circles. We're not dealing with the unit circle, as I said. So a circle is a set of all points, okay, equidistant to a fixed point called the center. The center is referred to as HK. You have a radius, which is half the distance from the center to the side. If you double the radius, you get the diameter. And so that should be prior knowledge. So how do we find R? Well, we could just use the distance formula. So if I called this x1, y1, and I called that x2, y2. I can find this. So I'm going to get, let's see, 0 minus y squared, or x squared, plus 0 minus y squared, or y2. So that's going to give me this. So if I squared both sides, I'd get d is equal to x squared plus y squared, which basically is the equation of a circle. Okay, d not representing the diameter, d representing the distance. Okay, so again, that goes along with that. So they're changing what d was as the distance, they're changing to r because r is the radius from the distance from the center to the. And this is a standard equation of a circle based at 0. And then if we were to look at the graph, the red circle is the circle for the top one. So this would say, hey, I have a radius of 4. This one would give me a radius of 2 root 5. Okay, or root 20. Root 20 breaks down to 4 times 5, which is 2 root 5. Is that okay? You want? Oh, good. All right.
Sorry.
Yeah, it's okay.
Wait, go back 2 slides. That one.
Oh, yeah.
So d squared, is that how you find r?
Yeah. So
So you use that bottom equation, right?
yeah. So that's actually calling.
So is that, okay.
So that's where the r squared comes from.
Okay.
Okay. All right. Here. No. All right. So then we have a standard equation of a circle where we have our center that is moved, and they use h comma k for the center of the circle. Okay. So I don't know why they chose h and k. I don't know what that resembles, other than the shifts. Okay. What's up, Bob? Capstone?
No.
Alright.
One of the 3 that I do too. Sorry for the interruption, Ross. How's life?
Good, man.
Oh, no, it's alright. It's alright.
Is it this one, or are you finishing the last one?
I have 2 that aren't finished, so just pick. I think it's the blue one.
I don't have, because you had started.
I had
right?
started. Yeah, I had started one, and I wrote finish later on the top.
Okay, I don't have it with me.
I can come back later.
Okay.
I'll come back tomorrow Thursday.
Cool. Hey, dude, you make A.
Remind me 8th. Will you remind me 8th so I make sure I have it?
Yeah, for sure.
Sorry about that, bud.
Sorry, class.
You did, man. All right. So sketch the equation. So my radius has to be 1. So it's a square root of that, so it's just 1. And my center is going to be at -1 comma -3. So I'm going to plot -1, -3 first. Get that, and then I get a radius of 1, so it goes 1 each direction. So this is just a little cycle.
I feel like we graphed circles in geometry.
You're probably right, because that deals with shapes. Good so far? Alright, let's see. Radius of this circle would be what? 3, right? So square root of that. And then my center is going to be at what?
-2 and -4.
And I normally would agree with that.
Oh, positive 4.
But what happened? Ooh, what is that going to do to us?
It makes it negative. So it's a positive.
Don't you bring it over?
Actually, this is a goofy problem because we have equal.
Huh?
There's 2 sets of equal signs in there, isn't there?
Yeah.
Yeah.
Just like switch it over there to make it like x plus 2 would equal
I
square
don't know
plus
what we were
y
thinking.
plus 4.
So what we're gonna do is just change this on yours.
Yeah.
Just change this whole thing to a plus sign.
Or you can just. Okay.
I'm just gonna change it to a plus because if we made it a subtraction sign, it isn't a circle. It actually becomes something called a hyperbola, which we're not working with yet.
A hyperbole.
All right, so let's see. -2, -4. Radius is 3, so 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. And draw your circle as best you can. Mine always kind of like it looks kind of okay. Yours might be a little oblonged because we're not used to drawing curves. Can I move on? All right. So sketch the graph of the equation. Well, it kind of looks like we already have it there. So I know that my radius is 4, and I know that my center is at 0, 2. So 0, 2 is right here. And then what they did is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So that worked out nicely. So if you don't have one of your components is just x squared or y squared, that value is going to be 0. So it's not going to shift right or left, or sometimes up or down, depending upon which one's not grouped. All right, write an equation of the circle with center at the origin and a given point. So what we have to do is we're going to use the distance formula, but we're going to use r squared. Is that okay?
Yeah.
So r squared is equal to x minus h squared and y minus k squared. Okay? Usually if it's the distance formula, it's r equals the square root. So if I took the square root of both sides, I'd have a root over the whole thing. So we're trying to find r squared at this point. So I'm going to call the center is at 0, 0. So that's h and k. This is x and y. So you just plug those values in. So you're going to get, let's see, we're going to get -3 plus 0 squared and 4 minus 0 squared. So that's going to give me r squared equals -3 squared is 9. And that's going to give me 16. So r squared equals 25. So r equals 5.
Wait, Mr. Sharp,
Yeah.
why don't you use the equation from, like, on the front of our notes? You wrote that r, d squared equals x squared plus y squared. Why don't we use that one?
So if you look at 1, 2, 3, 4, 5, the 6th slide, it's on the front, front, standard equation of a circle. That's what I'm using right there.
Really?
Yeah. So I'm going to use that equation twice. The first time I use it, I'm going to solve for r. And that finds my radius. And then I'm going to use this equation one more time.
Oh. So you use the x minus h one first?
Uh-huh.
Okay.
And then what I'm going to do is I'm going to plug in, it's centered at 0, 0, so I know the radius is 5. So I'm going to go 5 squared is equal to x squared plus y squared. Because my center was hk, which was 0, 0. Excuse me. All right, second one, doing the exact same thing. So I know I have 0, 0. And I'm still going to keep using this equation. First time I use it, that will find me the radius. So I have h and k, x and y. And so I'm going to get r squared is equal to 9 minus 0 squared plus -3 minus 0 squared. So that gives me r squared equals 81. And that gives me that being 9. So r squared is equal to 90. Root, we don't need the plus minus component because it's a distance. 90 breaks down to 9 and 10. So I get 3 root 10 is my radius. So I could say that 3 root 10 quantity squared is equal to x minus h, which is 0, plus squared plus y minus k, which is 0 squared. So if I square that, that's going to give me 90 is equal to x squared plus y squared. Why is this not squared? Well, I could go ahead and square it. Yay.
Okay. So if you have one that's like, here's a point that's not the origin, it would work exactly the same.
I bet you we're going to see that next. I would think. Can I move on?
No, it's something different.
Oh, okay. Ooh, identify the equation as for a parabola or for a circle. Okay? So this only has one term squared. So it's a parabola. This has two terms squared. So if you move that y over, you get a circle. This one is a parabola. And this one is a circle.
So I guess, does that work? Because a circle is kind of like parabola on top, parabola on bottom that meet in the middle, and it's just like a circle then?
Well, parabola, if you talk about with the focus, which was the point equidistance, which is the equation x equals 4py. Yes. Quit. You're generating a little bit further with it. All right. Write the standard form of the equation in the circle, then identify. Okay, so we have to complete the square on this. So my y value, I don't have a linear term. This is called a linear term because it's raised to the first power. This doesn't have a linear term. So I need to complete the square of this first. So that's going to give me x plus 10 quantity squared. So if I do that, that means I would have to add 100 and add 100 over here. Okay, so this over here would be x squared plus 20x plus 100 plus y squared equals, is that 81? So what I did is I'm completing the square of this. So I made my space, so push that over. So half of 20 is 10. 10 squared is 100. So if I took x plus 10 times x plus 10 and FOIL it out, I'd get this. Okay, so this is my complete square trinomial. So I get that plus y squared equals 81, which is 9 squared. So my, let's say, identify the circle, or center and radius. So h is, it's going to be negative 10. This doesn't do anything, so that's comma 0 is my center. And then the radius is equal to 9 because it's the square root of that.
Okay.
Good? Feel sorry for those who aren't here. Feel sorry for those who are sitting there staring at their phone the whole time. It's kind of rude. Just saying. I might want to start using my thing. Start using that maybe tomorrow. All right. I want to complete the square of this. I want to complete the square of this, and I'm going to move the 12 over. Leaving a space. Leaving a space. Move the 12 over by subtracting it. So that's going to give me, what, 46? Is that all right so far? I need to complete the square twice. Okay, so we'll do this one first. So this becomes x plus half of 2 is 1. 1 squared is 1. If I add 1 here, I add 1 here. Agree? Plus, let's complete the square of this. So we're going to complete that square. So that's going to give me y minus 3 squared. 3 squared is? 9. If I add 9, I add 9 over here. Is that okay? So the problem's pretty much done up until adding up. So 46, 56. So this would give me a center at negative 1 comma 3 and a radius of root 56. I guess you could break root 56 down to 4 times 14. So that would give me 2 root 14. That's 8 times 7 is indeed 56, but 4 times 14 is your biggest perfect square. You doing okay? Yep. May I move on?
Yeah.
We're really jumping ahead on time. That's good. Was there a wait?
No.
Okay, you good?
Yeah.
Okay. All right, so for this one, I'm going to reorder it. So I'm going to have my x's together, the quadratic and linear term, and my y's together, the quadratic and linear term.
Oh, so then you can solve it just like the other one.
So I'm going to get 3x squared plus 30x plus 3y squared minus 36y equals 9. Is that okay? So I just changed the order that I wrote it. I don't like having lead coefficients on my squared terms. So what I'm going to do is if I just divide everything by 3, that should work. So that's going to give me this. And I'm going to leave a space as well. Leave a space. Get there. Wave to the camera on your way by.
Lunchtime, dude.
What's up?
Jeez.
We went to the finest place downtown. This was not downtown.
Thank you.
One.
Two.
Oh, dude. Taking care of my waistline. Love it. So you guys have about 26 minutes of video to watch. All right. Say, why did I leave spaces?
So you have to
So you can do the back.
I want to complete the square, right? All right. So let's complete this square first. So I'm going to have
x plus 5.
x plus 5. What goes here?
10.
No, square
25.
25. So if I add 25 here, what do I do?
Add it to the other side.
All right. And gents who just came in, we had a discussion of phones. There's some people who are on phones too much, so we're keeping them away. Y minus 6, good. What goes here? Plus 36 and?
Plus 36
Agree?
on the side.
Oh, this doesn't seem that bad.
All right, so let's see.
64.
64?
Yeah.
Really? Yay. All right, so what's my center?
8.
-5, comma,
Oh, 6.
6. And then my radius is equal to?
8.
8. Love it.
Eat. 2 more than we.
No, it's just so they give you a whole word problem and you don't have to solve it.
What else do we got? Keep going. Wave. Yeah, buddy. Thanks, Kate.
My next problem.
All right. Uh-oh. Okay. Oh, shoot. Okay. A word problem. So we have a story problem. I can't wait to hear who the main character is. Must be a circle is the main character. The equation of a circle and a point on the circle are given. Write an equation of a line that is tangent to the circle at that given point. Tangent of a circle. Wait, tangent. Oh, man. Isn't tangent opposite over adjacent?
No.
That's the tripping on acid part or the TOA part?
Yeah.
Wait,
So is the tangent of a triangle related to the tangent of a circle? Yes. Okay. Now I'm not going to show you the philosophy, but what's taking place here is we basically have a circle and we have some line that's tangent to it like that. Okay. It doesn't have to be like that. It can be coming anywhere around it.
I thought that was a secant.
No, secant goes like this. It's a chord that forgot to stop.
Okay.
And a chord goes here to here.
Oh,
Okay.
Cool.
And the longest chord's called the diameter.
Circle.
It's outside of the circle. So it kisses the circle once. So here, so this is a tangent line. This is a chord. This is a secant. Takes you back to geometry. Okay? All right, so the equation of a circle at a point on the circle and a point on the circle are given. Write the equation of a line that is tangent to the circle at the given point. Okay? So we kind of have to think about this. I want you to visualize this. Right now, we have this kind of scenario taking place. I just drew this extra line in here. That's called the radius. Agree?
Yeah.
So what is, let's see. Oh, let's see. I could find the radius. The radius is square root of 17 on this problem. So things that we know, I know the radius is root 17, and I can't break 17 any further. That might not help us. Okay, so let's see, what else? Does anyone remember from geometry the relationship of a line that's tangent to a circle and the radius every time?
Yes, it's a 90 degree.
It's a 90-degree angle. Good. So this has to form a 90-degree angle. And 90-degree angles may make perpendicular lines. Right? So what? So the radius and tangent have perpendicular slopes. Is that okay so far? Bless you. So question for you. What is the center at this circle?
-4, 1.
No, that's the point on the circle. Look at the equation of the circle.
0, 0.
0, 0. Okay?
What's -4 and 1 then?
That's the point that's like here. This would be like -4, 0. Or -4, 1. And this would be 0, 0. And of course, I drew this completely inappropriate to how it would graph. Obviously, that -4, 1 would have to be on the left side of it. All right, so if I find the slope of the radius, I can find the perpendicular slope, which is the slope of the tangent line. Does that make sense? All right, so let's explore backwards. Slope equation's this. And I'm going to use the center and the point given to find the slope. So I'm going to go, let's see, I'm going to go like 1 minus 0 and -4 minus 0, which is -1/4. So what is the slope that's perpendicular to that? What's the slope that's perpendicular to -1/4?
4.
4. So the perpendicular slope is 4. Okay? Do you agree with that? Okay, so we have this tangent, which is a line. It's a straight line. That tangent right now has a slope that is +4. The radius at that point, that goes to that point, will have a slope of -1/4. Okay? So we have a perpendicular slope which is +4. Now, so I need you to see if you can reach this. Do I have a point that is on the tangent line?
Yes.
Yeah.
-4.
-4, 1. So this point right here is on the circle and it's on the line. It's the shared point. So you might remember the point slope equation? I'll show you. Y minus y1 equals m times x minus x1.
What?
That is the point slope equation
Oh,
of a straight line.
I do not remember that.
Okay? So I'm going to use this point, -4, 1, because that point is on the circle and the line both. And I'm going to use my perpendicular slope, which we just said our perpendicular slope is what?
4.
4. So the perpendicular slope will be the slope that's on the tangent line. The point that's given is also on the tangent line. So this is x1, this is y1. Plug those in. So I'm going to get y minus 1 equals 4 times x plus 4. And my friends, the most accepted way to write lines in math is using point slope. Don't convert it to slope intercept, which is y equals mx plus b. That's your answer. So that is the equation of the line that is tangent to the circle, that is centered at 0, 0. That also contains the point. The point of tangency is the point -4, 1, which that point of tangency is the point that is shared between the circle and the line. That's some good old-fashioned algebra right there. I like that stuff. You're like, dude, how am I going to remember that? Well, maybe I'll give you a point slope equation. Maybe I'll make sure you know what the equations are. And I don't know if you talk to your friends in other Algebra 2 classes, but they're testing today on what we tested on Friday. Yeah. So y'all are getting a little more education than they are. So, but they're given a simpler, modified version of the Chapter 12 quiz, which they're only going to have like 4 days of instruction on this chapter. So they're given a simpler version. So I will make sure I give you all the simpler version. Okay? But you're getting more education out of it. So you're getting...
So we should just have a story day tomorrow.
So you guys are getting 4 days more of instruction than those guys. Look at that.
Basically what you're saying is we're going to have a story tomorrow.
No, there's no stories because then we have to get the sequences in series. And I don't even know if they'll get the sequences in series.
Do you have any more stories? Yeah, he does.
Any more stories?
My brother
If they don't
asked
do
you
it,
if you actually, he doesn't believe that you actually flew
And
the
do-
plane.
I did a what?
That you actually didn't fly the plane.
You
should just do
Stop.
Jimmy Gusty?
Stop.
Oh, yeah.
If the other
I didn't fly.
classes,
Jimmy Gusty did.
if the other classes don't get to the stuff, is it gonna be in the final?
No, I will.
Tell us that story.
Is it gonna be on the final?
Let's see. Jimmy Gusty was a buddy of mine. So Jimmy Gusty came from a relatively wealthy family, and there was a private airport where they lived, and so we all went out to Jimmy Gusty's dad's plane when we were 15, and he's like, dude, let's get in my dad's plane. We're like, this is sweet. And he fires up the plane, opens it up, and I'm like, dude, I thought we were just gonna taxi around. Jimmy took off. It was a twin engine Cessna. We were flying all around Arizona.
No, you weren't.
That is
Yeah.
so scary.
Yeah, it was ridiculous. The funniest thing is Derek Smith threw up 3 times. Derek's in the back going, just land, bleh. Just bleh. Yeah, it was. All right. All right, sketch the graph. So we just did this one. Already done. Already done. Remember, this is the one that we got to modify this. I don't know, for some reason that should have been a plus sign. So -2, -4 down here. Right 3, 1, 2, 3. Up 3, 1, 2, 3. Left 3, 1, 2, 3. Down 3, 1, 2, 3. There's a circle. That it? Yay! Woo! All right. 12C. What do you think we do? All of them? We'll do all? No.
No, we should do odds.
Odds?
Even. We haven't done it.
You want evens?
Yeah.
Evens?
Front page evens, backside odds.
12C evens. And that's a front back front, so don't forget the 3rd page. Yay! Everyone here, did you do the Rip on Stirrup survey?
Yeah.
Yay.
Give them 100%. Duh.